Java variables are containers for storing data values. Containers means this abstract space where data could be stored in computer memory. These memory spaces are used to temporarily store data that could be manipulated or referenced at runtime. Let's introduce a couple of key points about Java variables, starting with how they're used. This is an example of a couple of variables that you see in a sample application. Given that this is a snippet, we're going to avoid all the other areas where you see decorations and the beginning part of the program. Starting with radius equals 1.0, this is a variable. And what we're doing here is to have two variables multiplied together times pi and assign the value of the computed result to this area, which is another variable. And then later on, we're going to print these variables using system out println. You'll see another examples below with similar settings, but with a different radius. You can think of these variables as a memory space that has a certain amount of storage. In computer science, the basic storage unit is bit, but due to hardware constraint, we use byte, which consists of 8 bits as the basic storage unit. These variables represent the identifier that references the specific location inside the computer memory which stores data. So radius in this case is 2, which is a floating number. We'll introduce some of these primitive data types. There's 8 of them in Java later on. But for now, just remember these variables represent temporary storage location where values are contained. These values doesn't have to be float, integer, it could be Boolean, it could be string, it could be characters. There's a lot of these data types we'll introduce soon. Let's move to the next property of variable, decoration. This is an example of how you declare a variable. That is, before using a variable, you must declare it by specifying the data type and name. For example, this integer x, which is a variable name or identifier, is of type integer. Radius is of type double. A is of type char. When you declare a variable, you set aside some memory spaces. So for the purpose of discussion, integer is 4 bytes. On some operating systems, this could be 8 bytes. Double is twice the integer size, typically 8 bytes to 16 bytes, platform dependent. Char, on the other hand, is 1 byte. So there is a range of fixed storage space for storing each of these types. And by declaring these variables with a type, you are setting aside this amount of space in a computer memory at runtime. Later on, we're going to talk about initialized versus uninitialized variables. But by and large, when you just declare a variable, there's no value associated with it. In Java, there's default value, but technically you haven't really assigned any values in these storage locations. So having an uninitialized variable means declaring a variable without assigning a value to it could cause compilation errors, especially when you start utilizing these variables without cost. We'll get into this a little more later on when we see examples of variables are used. Let's quickly jump into the next slide where we talked about initializations and assignment. What you see here is 3 assignment statements. Statement means this entire line of code concluded with a semicolon. So statement means this entire line of code will be evaluated by your Java program. Same thing here, another statement, another statement. Now, assignment statement simply says that you're assigning the value, which is on the right-hand side, to this variable on the left-hand side. So what you're doing is you're assigning a value of 1 into this variable's x. You're assigning the value of 1.0, which is a floating, into this radius variable. And you're assigning this character a, signified by a pair of apostrophe, or this is a single quote, into this variable a. So this equal sign is the assignment operator, equal sign operator. In some textbook, they also call it unary operator because there's only one. So whenever you see an equal sign, that means some value is assigned into a variable, period. In a more involved programming context, they call these R values, and this variable being the L values. Both R and L values are beyond the scope of this discussion here. Let's quickly look at an assignment's cousin, what we called initialization, in the next slide. Here are two variables or declare variables, integer x and double y. When you just declare them, you're setting aside 4 bytes of memory space for x and 8 bytes of memory space for y. When you do the assignment, these memory spaces, the first one being x, the second one being y, are given the value, x being 1, y being 1.4. That's what happens when you have declaration and assignment. You can also combine both declaration and assignment all together in one single initialization statement, this, which is the example that you saw from the previous slide, but without a declaration. So the complete initialization clause starts with declaration and it ends with an equal sign, which is the assignment operator. This is a very convenient and safe way of creating a variable and assigning a value to it immediately so that you don't forget this variable's value when you make use of it in other expressions or code snippets. As a best practices, it's always good to initialize your variables with something. Even if you don't know what that value is going to be later on, it is always good to have a sentinel or placeholder value that represent the baseline of what this variables ought to be in any programming language to avoid any compilations and or runtime errors. This shall conclude our discussions of variables and their properties in Java.